providing solutions for the delivery and management of online video. We were founded in April of 2007, which puts us just a shy over 4 months old. The original founding team, we were actually here at Stanford for CS and went on to Google for a short careers between 2 and 4 years in engineering. But since then, we founded the company. We've grown the team significantly. We're at about 18 employees right now, heavy engineering staff of about 13. Before that, we actually launched our first version. We opened up to a small set of beta users of Ooyala Video, which I'll give you guys a demo of in a second, as well as Ooyala Backlog. We launched shortly about a month afterwards. And so, let me show you our lovely office. Okay, so quick demo of what we're doing. We entered the video space with the goal of revolutionizing the way in which video is consumed, engaged, and consequently monetized. So the way we actually do this is by building on top of an interest-driven experience. Users get HD to DP quality video, and user action actually triggers the highlighting of objects in which they can actually interact. And once a user interacts with objects, they are able to, excuse me, I get my volume. They're actually able to find out more information about the content in which they're interested.
Yes.
So as the user clicks on an item, they would pull out more information about the object that they're interested in. So we give them information from static sources, given IMDb, Wikipedia, Edmunds, Takar, for example, as well as provide more community features to increase interaction and engagement. And lastly, monetization, but it's far more targeted than what you traditionally see with videos. So while we were building out this product, we initially started, the entry point obviously being a way to get your content up and into the system. So we started with Ooyala Backlog, and we built a very simple uploader for basic content management, uploading, and organization of your content. But we quickly realized video is a very nascent industry, and so it was there was a lot of very easy problems that we could solve in the meantime for the content providers that were a very low-hanging fruit. And would also help us gain a lot of our adoption. So we began to expand our feature set. And so we launched more controlled syndication. We're introducing detailed reporting and analytics into the process. And lastly, content mixing. So the ability to essentially mix your ads into your content. So the way in which we really like to approach the problem is an iTunes meets enterprise application. This stuff shouldn't be hard. It's not supposed to be. And so we're aiming to really revolutionize this space. Enabling the innovation. So, and this is what we're all here for. What have we been doing? Well, first, it takes a lot of caffeine. It takes a lot of caffeine. So, but second, it's about picking the right tools. And so we did this from day one. We started off by picking the right technologies, be it Flash, Flex, Rails, Apache, MySQL, and of course, Amazon Web Services. So one of the questions for us was, why do we want to do AWS? And the initial one was, well, I already actually claimed the server room as my ledger. But beyond that, what it really came down to was the decision for the other technologies was fairly straightforward. Right? Flash Flex having 98% browser penetration. Rails has a great developer community and it's growing very quickly. Apache and MySQL very obvious decisions, they're the standard. But with Amazon, we were a little less certain at the start. What it really came down to is we looked back at our past, and our roots being Google, a company that does a lot of their development in-house, we were very apprehensive of essentially building our products on some infrastructure that we did not control. But the more we looked at how they were able to innovate so quickly, it really was rooted in the fact that they had built on top of a lot of these fundamental building blocks. Right? You can draw something with direct comparison. So a lot of the tools that we already had available, and we found that these were things that we already knew how to use. They're the fundamental building blocks that simply let us innovate in our area of expertise, rather than wasting our time in the muck. So how are we actually using AWS? And there's three phases that I'll highlight here. First is how do we get content into the system? And so the way we do that is via a Flex application built on top of Adobe Air that then uploads directly to EC2 or directly to S3. So the way we do this is we get a large batch of signed URLs from EC2 to essentially upload to S3. I'll explain why we do this in a second. We push the files up to S3, and then encode a message in SQS for later processing. The reason we actually do this instead of uploading directly to EC2 is that lets us scale at approximately 100x capacity, because all we're doing is sending URLs. You can run this on a very lightweight URL server that can handle millions of requests a day, as opposed to trying to handle that. Sorry about that.
Okay.
Yes, it is the cat meme. So that's the first step. And obviously, the data is already available for us to use. It's already in S3, and we can leverage it from there. So that takes us to our second use, which is our actual video processing. And this actually, we have a very similar approach that Mike mentioned before. And it's based a lot off of David Kavanaugh's article, as well as Mitch Garnett's long-term mashup and the automated server pool. Essentially what we do is we have a single server running and monitoring the SQS queue using a modified version of Lightbearer that then brings up more instances. We then will download the files from S3 and we'll begin processing them. We encode them in a variety of formats, but what we also do is run them through a lot of our computer vision algorithms. And essentially what this does is we take a single video, we chop it up into a number of its individual scenes, and kick it off to dozens, if not hundreds of machines that whole terabyte to process at the same time. From there, we take the data, we push back into EC2, up into S3, and into a message that we're done with SQS. Again, massively scalable, and enables a lot of the parallel processing. Alright, so then the final step, actually delivering video content. Because it is, I think, like most folks in the video space, this is a challenge. Bandwidth is a huge factor. And the way that we wanted to approach this was, let's be able to scale very easily. We want to limit the number of moving parts. And for that, it also means the number of EC2 instances that we have to maintain, keep up, load balance, etc. So, again, what we do is leverage our EC2 instances to provide signed URLs to the client, which then will pull the files from S3 itself. What this allows us to do is get essentially a 200x serving capacity per EC2 instance. So we're able to host a huge amount of traffic on just a very small subset of those servers. So we also do use AWS for a handful of other things. First, we use it for all our dev machines. Actually, every single development machine is hosted on EC2. We use S3 for frequent backups. And we do use Mechanical Turk to assist us with market research. Everything down to when we wanted to pick a new logo. We put up a large batch of requests on Turk to simply vote for the favorite logo. So, to tie all this together, when we were leaving, we heard a lot of warnings from friends, coworkers who had also ventured out into the entrepreneurial space a long time ago to essentially say, you guys really are going to be spending 70-30% of your, or 70-30 split with 70% of your time in the data center, late nights, turned early mornings, plugging in the cables, keeping things up and running. And what we've really found is we're still spending those late nights and early mornings, but it's actually building the product, executing our vision, and really enjoying some of the fun of the startup life.